Welcome back to Business Mathematics 2 MA 1203. So for this occasion, we will proceed with other matrix operations, that is transpose, determinant, and inverse. So for today, for this session, we would like to proceed to transpose and the determinant of a matrix. Okay, yeah. Let's see. Try computing transpose of this matrix. Okay, yeah. The notation is prime or small letter t or capital T. So if you have a prime or small letter t or capital T, it means you want to find the transpose of this matrix. Okay, when you are dealing with transpose of matrix, is changing the column into row and row into column. So here you have the first row become the first column. The second row become the second column. The third row become the third column. Or you can look at this like here. The first column become the first row. And the second column become the second row. Okay, that is what we usually do when we are computing transpose of matrix. Try to do this. Okay, and the notation for transpose is prime, capital T, or small letter t. Okay, and then we would like to proceed with the determinant of matrices. Of course, when we are talking about determinant of matrices, we are talking about determinant of square matrix. What do you mean by square matrix? Square matrix that have the number of row is the same as the number of column. So for 2 times 2 matrix only, 2 times 2 matrix only, we have just the diagonal minus the anti-diagonal. That is A times D minus B times C. But it only works for 2 times 2 matrix. Okay. What about for 3 times 3 matrix? For 3 times 3 matrix, you can do Sarus method. Okay. That is, if you have already, if you remember, you have this. If you want to find the determinant, the symbol of determinant is using this one, yeah. You are not using this one. No, not this notation. You have this notation for determinant. So if you have A, B, C, D, E, F, G, H, I want to look at. I want to use a scratch here. I want to have an auxiliary column A, D, G. This is the first column, and B, E, H. Okay, so how do I find the determinant of this? This is this one plus. So you have the determinant is plus A times C times A, B, C, D, E, E, plus B times F times G plus C times D times H minus this one minus so this should be plus and the minus is minus CEG minus AFH minus BDI. Okay, but don't forget it only works for 3 times 3 matrices. 3 times 3 matrix. For 2 times 2 you have this diagonal minus anti-diagonal. For 3 times 3 you can use Sarus method by adding 2 auxiliary columns, the first and the second, like I have already told you. And for the general n times n, so you should use the what we usually say the cofactor expansion. Let's look. Okay, so if you want to find the determinant of 3 times 3 matrix, let's say you have A, B, C, D, E, F, G, H, I. Don't forget, this is the symbol of determinant. Okay, yeah. What is the symbol? Okay, you can have the cofactor expansion way. Okay, using let's say that cofactor expansion using first row. So the first row is this. This is the first row. Okay, yeah. Don't forget, I have to have this first. If I have 3 times 3, plus, minus, plus, minus, plus, minus, plus, minus, sorry, plus, minus, plus. So, let's see. You have, maybe I will use red one, yeah, instead. So you have plus, minus, plus of A, B, C. Okay, yeah. The sign first, plus, minus, plus, plus, minus, plus, plus corresponds to the first column, first row. B, negative should be the first row, second column. Plus should be the first row and third column. And what is this is you have to multiply with the submatrix, the 2 times 2 matrix. How do I find the 2 times 2 matrix? You want to have, if you want to A, you have to times the submatrix. This is for the first column on the first row, first column and the first row. So you should eliminate first column, first row. So you have E, F, H, I. How do you determinant of this? Easy. This is just 2 times 2. E minus E times I minus H times F. Diagonal, multiplication of diagonal, minus multiplication of anti-diagonal. What about this one? B multiply with, I will try again. Okay, yeah. B is the first row and the second column. First row and second column. So you have to eliminate the first row and the second column. So you have D, F, G, I. Okay, yeah. And you can do the rest the same as this. Yeah, this is the cofactor expansion if you are using the first row. So when you are doing cofactor expansion, you can use the first row, the second row, the third row, the first column, the second row, the column, the third column, any way you like. Don't forget the sign. Don't forget the sign. And what is meant by the submatrix. Let's see. I will have to select this. Delete. Okay, now I would like to give you another example. If you want to find cofactor expansion using third column. Okay, what is the third column? The third column is here. This is the third column. Let's see, I just use purple. The third column. This is the third column. Okay, C, F, I. So don't forget the sign first. The sign first. Define the sign plus minus plus. Plus minus plus. And what do you have here? C, F, I. Well, you have to multiply with submatrix. 2 times 2 submatrix. Okay, so if you have C here, you have D, E, G, H. F, you have A, B, G, H. I, you have A, B, D, E. Okay? And you will have the same result. Whether you are using the first row, the second row, the third row, the first column, the second row, or the second column, or the third row column, you will have the same determinant value. So you can choose whatever you like. But what about if you have determinant of 4 times 4. H, I, J, K, L. Don't forget it should be square matrix. M, N, O, P. Is this true? Yes. So the same. You have to find this first. You have to expand this plus minus plus minus minus plus minus plus. So if you want to have the first, so you have minus plus minus. What is this? A, B, C, D. What is the submatrix? When you are dealing the submatrix, you want to eliminate the first column and the first row because A corresponds to the first row and first column. So you have F, G, H, J, K, L, N, O, P. This one. Because you eliminate this, you can do the rest for this. But don't forget, it will become a 3 times 3 matrix. So it really, okay, cumbersome. Okay, that is the cofactor expansion. And then try to evaluate this. Okay, there is a neat trick here. But you just have to try. Just have to try. The notation for determinant is this one, yeah? Or this one. Okay. Okay. Then you have the relation between determinant and other matrix operation. If you have this, do you have this? If you have determinant of this plus determinant of this, is it the same as determinant of the addition of this? Try to do this, yeah. What about the multiplication? Is determinant times determinant this equals the determinant of the multiplication? What about the transpose? Is it the same? You have to try it by yourself. You have to try it by yourself. Is it the same? Some is not the same, some is the same. Okay, yeah. And this one, the determinant, the relation between determinant and elementary row operation. When you are exchanging row, when you are multiplication of a row, when you have the third elementary row operation. So the first arrow will change the determinant. How will it change? The second will change also. The third elementary row operation will not change the determinant. So when we are dealing with determinant of a matrix that usually maybe have 1,000 times 1,000 matrix, so we do not use the cofactor expansion, but we use the relation with the elementary row operation. Okay, this is just for your knowledge. This is just for your knowledge. You don't have to worry about this. Okay, next one is the inverse of matrix. I will discuss it on the separate video. Thank you.